Hello everyone. Here we are going to represent hardware software co-design of pipeline instruction decoder in system emulator. Here this is one paper, IEEE paper, and we are going to represent it. This paper presents hardware software co-design of pipeline instruction decoder to avoid the inefficiency of system emulator based on software. So the decoder is controlled by software unit and supported by hardware unit via cross programming. So compared to system emulator based on software, the average speed up of pipeline instruction decoder achieves 5.2, and there is a significant performance improvement on this system emulator. This is about this paper actually, why we are studying this paper. Second one is this is the hardware software co-design of instruction decoder. This is the diagram which consists of we can see the different registers, that is the CPU register, physical memory, IO interface. All the components are there. Along with that, we have decoder controller, which is the main part of that part of our paper, and all other components are the part of that system, whole system. But we are basically uh, more interested in decoder controller and adding the custom instructions. So we are adding both part, that is software and hardware. Software part will consist of decoder controller, and hardware part will consist of adding custom instruction. So these are both coupled with the help of cross programming. So it is called so that's why we have mentioned here, with the help of cross programming we are doing this instruction decoder. This is about software hardware unit. How should be the emulator? This is the format of x86 instruction emulator. Now, as we know that a lot of applications are running, most of the applications are running on 86 format or 86 processor. But nowadays, it's required that all the applications should run on other applications also. So, whatever applications which are running about on in 86, then what we can do about that? For that purpose, we can virtually run this emulator, 86 emulator, and we can run whatever application was running on that 86, we can run on that same. So this was the concept of that form 86 emulator. And this is the instruction format of 86, which consists of instruction pre-page, upcode, and then displacement, immediate, SIB, and all these fields are there. Good. So about this 86 format, is the 86 instruction system is a classical 6 instruction set, and including the instruction of data transmission, arithmetic, logical operations, flag register transmission, symbol extension, and so on. So it's vary from distributed from 1 byte to 15 byte. When encoding instruction which used frequently have shorter instruction format, and which is used rarely have longer instruction format. The variable length instruction set could shorten the length of instruction flow effectively and reduce the cost of memory access, enhancing the efficiency of instruction encoding. However, it increases the difficulty of instruction decoding. So general format of its instruction is shown in figure what I told, which includes the field of instruction, or what I told, prefixes, upcode, mod r slash m, SIV, displacement, and immediate. This is the FSM of serial instruction decoder. Uh, this It is the variable length instruction determine that we cannot get the length of instruction in advance, and as we are not getting the length in advance, it's very difficult to predict that how much that instruction should be. And so decode the we have to decode the instruction completely. uh, So the basic design is it's reading the byte by serial and get the meaning of instruction by state conversion. Uh, this is what in diagram is the FSM, that the final state machine of serial instructor decoder. This FSM of state transition of 86 serial instruction decoder. State depends on the input of previous byte. We cannot get the length of instruction ahead of time. So this is the mechanism of that 86 instruction decoder shows that the serial instruction decoding is clearly and implementation of electric circuit is very simple, but the efficiency is very low and cannot achieve the need of processor seriously. Assuming that length of instruction is n and n plus cycles are needed to complete the decoding of instruction, and the time complexity will be a big O of n plus 1. This is the techniques of parallel processing. Here we can use the resource replications. Now we will think about how to increase the speed of execution with the help of this pipeline concept. Actually, pipeline concept is used to increase the throughput of a system. Means that systems we develop some system like that we create lot of we create some stages, and that each stage will be executed with every clock cycle. So, for example, we have created pipeline of three stages, pipeline of four stages, pipeline of five stages. So, in each stage, we perform some operation. So, for first for initial state, it will take some few clock cycle uh, for filling the pipeline. But after this pipeline gets filled, then after each clock cycle, we will get output from that system. So that pipeline concept or creating stages, it depends upon the what the application you are having. If your application is very small, then the pipeline concept cannot be useful, because it will take some time to fill the pipeline. So that time its efficiency is very low. But once it gets filled, and that after that we will get 100% output or more efficiency as compared to other. So now, to choose which type of pipeline, how many stages should be there in pipeline, it depends upon application and user. So but actually, pipeline increases the efficiency of any processor if it is used in perfect way. So there are few techniques are there. For example, techniques here we have shown that parallel processing techniques. First is the resource replication, and second is time interleaving. In order to speed up the efficiency of instruction decoding unit, this paper is there. This technique of parallel processing, such as design ideas of research application and time interleaving. The resource replication takes into account of a spatial factor in the procedure, works in parallel to improve the efficiency via adding the few sets of same hardware unit and winning the quantity driven. Mm, then what is time interleaving? Time interleaving introduces the factor of time and different units of same hardware device complete the whole process in several pipeline stages. So different components have clear division of labor and improve the efficiency by raising the utilization of hardware system. So this is about that. So this paper design a schema for instruction decoder with the pipeline stages to achieve high efficiency by upgrading the parallelism of time. So so these are the different stages of pipeline. First stage is the prefetch, second is the length decoding, third is the instruction extracting. So the three stages are there in pipeline. Uh, This is the structure of whole pipeline instruction decoder. And the first part is prefetch, second part is length of decoder, and the third part is the extract. So prefetch, in prefetch it takes the which type of instruction is there. In length decoder it finds how much length of that instruction is there, and third is the extraction is done. Like that, it's the whole structure of that instruction decode is there. As I shown there, first part is called as prefetch, which is called as instruction prefetching also. This instruction prefetch cheaply obtains instruction flow from memory system correctly and continuously, and generates instruction address, and is made up of instruction cache and generation of instruction address. So the data flow of instruction that retrieved from the memory system is stored in the instruction cache. The instruction address have sequential address and jumping address. We introduce dynamic branch prediction module to predict the jumping or not by retrieving the result of instruction decoder, so decreasing the invalid probability of address and enhance the efficiency of instruction fetching unit. This is about first part of instruction fetching. And in instruction decoder has actually what I told, three pipeline stages, and can get the length of instruction during the stage of length decoding. So instruction cache should be twice the length of 86 instruction cache. So longest instruction is 15 byte, so cache is set up to 2 into 16 byte, that is 32 byte. The structure of instruction cache is shown in figure. This is the second. Here we have format of instruction cache. This is again we have the structure of the length and address of instruction n minus 2 are known when prefetching the instruction n, and some of them is address of instruction n minus 1. The program is sequentially executed. The length decoding stage of instruction n minus 1 has completed after instruction n is prefetched. So the 16 byte instruction n should be distinguished from the 32 byte instruction flow, and when instruction n process the length of decoding. So this is about the format of instruction. Second part is the length decoding. This part, the unit of this instruction length decoding includes the we can see that include the left shift register, counter is there, prefix is there, and included counter identifying prefix is there, the identifying mode of operation is there, calculating length of displacement and immediate functions of instruction separation and recognition of operation mode, and calculation of instruction length are completed in this stage. So according to rules of 86 instruction encoding, the length of instruction could be known after the input of SIB, including the instruction prefixes, opcode, mode, SIB field, etc. The diagram of instruction length calculating is shown in figures. Shown in figure. What right? Shown in figure. This one. So this is about length decoding. Then third part is called as instruction extracting. What it means, the unit of instruction extracting is the responsible for the processing of extracting the sys instruction, which length is confirmed. After obtaining the length of instruction, we can extract the prefixes of code and SIB and displacement and immediate fields as a risk instruction decoding, and write back to the memory unit. So this is about the extract. So at the end, this after this paper tells that hardware software co-design pipeline instruction decoder has this is proposed to speed up the efficiency of 86 instruct system level emulation based on dynamic binary translation. So experimental results shows that the decoder works efficiently and gets satisfactory average speed up of 5.2. So it will significantly shorten the time of instruction decoder and improve the performance of 8086 system level emulator. So at the same time, method based on hardware software co-design provide the reference idea for study on compatibility of new architecture processor. So this is about that pipeline structure. So at the end, we can say that pipeline is it can be efficient or cannot be efficient. Again, it depends upon the which type of architecture we are using there. So on the basis of application, on the basis of user requirement, we can decide which type of pipeline structure we can use on the basis that we can select correct or appropriate pipeline structure, and we can use the processor more efficiently. So this is about that pipeline software and the co-design of pipeline and instruction decoder. Thank you very much.